Hello everyone, welcome to this class on finite element analysis, and in this class let's learn this problem on minimum potential energy, that is determining the nodal displacements using the principle of minimum potential energy. So the question is, for the spring system shown in the below figure, using the principle of minimum potential energy, determine the nodal displacements. So in the last problem we solved we had a spring system with totally 3 springs, but here we have a spring system with total of 4 springs. So 4 springs in the sense there would be 4 deflections and 4 stiffnesses, and you can just see there are totally 1, 2 and 3 nodes. 3 nodes in the sense there would be 3 displacements and 3 forces acting. Therefore, the potential energy equation pi is given by strain energy plus work potential. So that one I think you will be knowing it well. So strain energy totally depends on the total number of springs. There are totally of 4 springs, and this strain energy is generally given by, let me write it here, half k delta square. As there are four springs in this problem, here you will get half k1 delta 1 square plus half k2 delta 2 square plus half k3 delta 3 square plus half k4 delta 4 square. And work potential, it depends on the number of nodes. There are totally 1, 2 and 3 nodes. Therefore you will get minus f1 u1 minus f2 u2 minus f3 u3. Suppose if there are 4 nodes, you will also get minus f4 u4. Now just substituting both in this equation, you get pi equal to half k1 delta 1 square plus half k2 delta 2 square plus half k3 delta 3 square plus half k4 delta 4 square minus f1 u1 minus f2 u2 minus f3 u3. So this is what is the final potential energy equation. Now for this potential energy equation to be minimum, for PE to be minimum, this dou pi by dou u must be equal to 0. But before that we have to do one more thing. Before even substituting that, we have to substitute for this delta 1, delta 2, delta 3 and delta 4 in terms of displacements. So displacements u1, u2, and displacements here it is u2. At node 2 you have u2, at node 1 you have u1, and at node 3 you have u3. So before going into that, before actually solving this problem, you have to substitute that. So delta 1, the deflection at delta 1 in terms of displacements is nothing but the displacement on the right hand side minus displacement on the left hand side. For delta 1, displacement on the right hand side is u1 and displacement on the left hand side is u2. Therefore you get my u1 minus u2. Next, delta 2. Delta 2, the displacement on the right hand side is u2, and on the displacement on the left hand side you don't have anything. Therefore it is u2 minus 0, which is u2. Next, delta 3. Delta 3, the displacement on the right hand side is u3, the displacement on the left hand side is u2. So this is u2. So u3 minus u2. So it is going to be u3 minus u2. And delta 4. Delta 4, the displacement on the right hand side you don't have anything. The displacement on the left hand side is u3, 0 minus u3, which is going to be minus u3. So finally you have got all the 4 displacements. Delta 1 equal to u1 minus u2, delta 2 equal to u2, delta 3 equal to u3 minus u2, and delta 4 equal to minus u3. So substituting all those in equation number 1, this I'll consider to be equation number 1. So after substitution, what do we get is half k1, in place of delta 1 I'm going to write it as u1 minus u2 the whole square, plus half k2, in place of delta 2 square I'm going to write it u2 square, plus half k3 u3 minus u2 the whole square, plus half k4, in place of delta 4 I'm going to write it as minus u3 the whole square, minus f1 u1 minus f2 u2 minus f3 u3. Now let's try to simplify this equation. You will get pi equals to half k1. So here I'm going to apply a minus b the whole square formula. That is, it's in the form of u1 minus u2 the whole square. Therefore I'm going to apply a minus b the whole square formula. u1 square plus u2 square minus 2 u1 u2 plus half k2 u2 square plus half k3, and here I'm going to apply a minus b the whole square formula again. It is going to be u3 square plus u2 square minus 2 u3 u2. It is nothing but a square plus b square minus 2ab, and here plus into minus will be minus half k4 u3 the whole square will be u3 square. Next, minus f1 u1 minus f2 u2 minus f3 u3. Now let's try to multiply this half k1 inside this bracket, half k3 inside this bracket. So finally we'll get a bigger equation. So therefore pi equals to half k1 u1 square plus half k1 u2 square. So when half gets multiplied with 2, 2 and 2 gets cancelled. Plus into minus will be minus k1 u1 u2. I hope you understood that. Next you have half k2 u2 square plus half k3 u3 square plus half k3 u2 square minus, plus into minus will be minus, 2 and 2 gets cancelled, therefore you get k3 u3 u2, k3 u3 and u2 minus half k4 u3 square, and you also have minus f1 u1 minus f2 u2 minus f3 u3. So I have just simplified the entire equation now. So this equation is what I'm going to differentiate now with respect to u1, u2 and u3. So let me just rewrite this equation back in the next page. I'm going to get pi equals to half k1 u1 square plus half k1 u2 square. Fine, now I have written the entire equation, whatever was written in the previous page. So this pi equation, now I have written it over completely here. So this is the complete simplified equation of pi. Now for minimum potential energy to be, for potential energy PE to be minimum, so because we are solving this with respect to minimum potential energy method. So for this potential energy to be minimum, this pi, dou pi by dou u must be equal to 0. Here we have totally of 3 displacements, u1, u2 and u3. Therefore, dou pi by dou u1 must be equal to 0. Dou pi by dou u2 must be equal to 0. And dou pi by dou u3 must be equal to 0. So partially differentiation of this equation with respect to u1, u2 and u3 must be equal to 0. So u1, so partial differentiating this equation with respect to u1 in the sense only u1 will be considered, wherever you have u1 only that will be considered as variable. Apart from u1, whichever other things will be considered as constants. For example, here in this equation dou pi by dou u1, now here it's going to be, here we have u1, so therefore half k1 will be considered as constant and differentiation of u1 square will be 2u1, and here you don't have u1 anywhere, so therefore that's going to be 0, minus here k1 and u2 are going to be considered constants. Differentiation of u1 is going to be 1, plus here there is no u1, therefore it will be 0, plus here also there is no u1, it's going to be 0, here also there is no u1, it's going to be 0, and even here there is no u1, and here also there is no u1. So plus or minus 0 will not matter. And finally here we have only u1 in this first term, therefore minus f1 will be considered as constant and u1 will be left out. So finally that is going to be equated to 0, and finally you have 2 and 2 gets cancelled. So you get k1 u1 minus k1 u2 minus f1 equal to 0. If you send this f1 to the other side, I'll get k1 u1 minus k1 u2 equals to f1. I hope you have understood this. Okay, next let's try to do dou pi by dou u2. Before that, let me try to write this equation, this final equation, that is k1 u1 minus k1 u2 equal to f1. So this one let me try to consider as equation number 2, because already we have considered this as equation number 1. Therefore, let me consider this as equation number 2. Now, let me try to even highlight this answer, because at the end it will be very, very helpful for us. Next let me try to highlight this and this equation as well, because this equation is what we are trying to differentiate partially with respect to u1, u2 and u3. Let me try to partially differentiate that equation with respect to u2. When you try to partially differentiate that equation with respect to u2, only u2 will be considered variable and all other terms will be considered as constants. So here the first term you don't have u2, it will be 0. Second term you have half k1 to be considered as constant. Differentiation of u2 square, u2 square is there, so therefore that will be variable. Differentiation of u2 square will be 2u2. And in third term k1 u1 will be considered as constant and differentiation of u2 will be considered as 1. And similarly, in the fourth term, half k2 will be considered as constant, 2u2 will be written as it is. And in fifth term, you don't have u2, therefore that will be 0. And in sixth term, half k3 will be considered as constants, and 2u2, that will be written as it is. And here in sixth term, k3 u3 will be considered constant, and differentiation of u2 is 1. And in this term k4, that will be 0. And here only you have here as u2, therefore only f2 minus f2, because here you don't have u2, here you don't have u2, and here you don't have u2, so that will be equated to 0. Now let's try to simplify. 2 and 2 gets cancelled here, 2 and 2 gets cancelled even here, 2 and 2 gets cancelled even here as well. So only the remaining terms like k1 u2 minus k1 u1 plus k2 u2 plus k3 u2 minus k3 u3 minus f2 equal to 0. So therefore I'll just send that minus f2 to the other side, or let me try to write it. So this minus f2, if it goes to the other side, it will be plus f2. So here you have different terms. So first let me try to write the first term, that is u1. Wherever you have u1, that you try to write first. Therefore you have minus k1 u1. Then you can try to write this u2 terms. So u2 terms you have totally three terms you have. So what I'm going to write is, I'm going to write k1 u2 plus k2 u2 plus k3 u2. So therefore totally of 5 terms, I have written 4 terms, and let me try to write this k3u3, and this minus f2, if I try to send it to the other side, it's going to be plus f2. And here I'm going to take u2 common. I'm going to get minus k1 u1 plus, if I take u2 common, I'm going to get k1 plus k2 plus k3, and I'm going to write that common u2 term here, k1 u2, k2 u2, k3 u2 minus k3 u3, that is going to be equal to f2. So let me try to highlight this equation, and then let me call this equation as equation number 3. Next, let me try to partially differentiate dou u3. So this equation with respect to u3. So finally what I'm going to get is, here this first term, only u3 is going to be considered as variable. This first and second terms, third terms, fourth terms, till everything, all these terms are going to be considered 0, because there is no u3 variable. Here you have u3 variable, therefore it's going to be half k3, and differentiation of u3 square is going to be 2u3. And here it's going to be half, and okay, this is going to be considered as 0, and here you have u3, therefore that is going to be considered as minus k3 u2, and differentiation of u3 is going to be 1. And here half k4, differentiation of u3 square is going to be 2u3. And here this first two terms are going to be considered constant, and the third term you're going to write it minus f3, that is equal to 0. So now 2 gets cancelled, 2 gets cancelled, so only this k3 u3, I'm going to write it first. Next I'm going to write this minus k3 u2. Next I'm going to write minus k4 u3, that is minus f3 equal to 0. So now what I'm going to write is, I'm just going to write first, there is no u1 term here, therefore first I'm going to write this u2 term, minus k3 u2. Next I'm going to write this plus k3 u3 minus k4 u3. This minus f3, if I'm going to send it to the other side, it's going to be plus f3. Finally I'm going to get minus k3 u2 plus u3. I'm going to take u3 common over here, therefore I'm going to get k3 minus k4 equal to f3. So this I'm going to consider as equation number 4. So now what I'm going to write all these three equations. Okay, now I have written all those three equations over here. I have just done a small mistake. Let me just rectify that. Here it has to be plus, because here it is actually plus. The reason for that is, actually I'll just tell you. Here we have just taken it minus. Let me just make it plus first, and then let me tell you where I have made the mistake. So here it is half k4 u3 square. So here it has to be plus. The reason for that is, in the main equation initially I had made a mistake. So here minus u3 the whole square will be minus into minus, it's going to be plus. So plus into plus, it's going to remain plus. That was the only mistake which I did. So therefore if it's made plus here, even here it's going to be made plus, and here and finally here we are going to get as plus. So the first two equations are right, only here I had just made the mistake. I hope you have understood that. So now let me try to solve these three equations. So before solving, and here it's going to be made plus. Okay, so before even solving those three equations, let me try to substitute those values. Here I can just substitute all these values according to this problem. So according to this problem, whatever the given values I can substitute. So k1 is given as 40. So 40 u1 minus 40 u2, it is going to be f1. F1 is 60, and here it is given as minus 40 u1 plus k1 plus k2 plus k3, 40 plus 40 plus 80. So 40 40 is 8 is 160, 160 u2, 160 u2 minus 80 u3, that is going to be equal to 0. And next we also have k3, that is minus k3, minus 80 u1 plus minus 80 u1 plus k3 plus k4, 80 plus 90, that is 170 u3, that is going to be equal to 50. So therefore now you have to use the equations, so equation method to just solve it. And here it is u2, yes, it's u2. Okay, so now using this equation method, let's try to solve this problem. So here we can just rewrite this equation as 40 u1 minus 40 u2. So I'll just try to write plus 0 into u3 equal to 60. The second equation I'll try to write it as minus 40 u1 plus 160 u2 minus 80 u3 equal to 0. This third equation I'll try to write it as 0 u1 plus 80 u2 minus 80 u2 plus 170 u3. Let me try to write that as 50. So now using your calculator, using equation, number of unknowns, equation mode, number of unknowns, you can try to take it as 3. This you can consider as a1, b1, c1, d1, a2, b2, c2, d2, a3, b3, c3 and d3. So using that you can try to find the answers in the form for u1, u2 and u3. So let me try to change the mode. So let me just try to give one. Number of unknowns are 3. So a1 is 40 and b1 is minus 40, c1 is 0, d1 is 60 and a2 is minus 40 and b2 is 160, c2 is minus 80 and d2 is 0 and a3 is 0, b3 is minus 80, c3 is 170 and d3 is 50. So finally I'm going to get x in the sense it is nothing but u1 I'm getting it as 2.514 mm. So let me just try to equate it. So y I'm getting the answer as 1.014, that is u2 is 1.014 mm, and u3 is nothing but z is nothing but 0.771 mm. So this is all about solving this problem, finding the nodal displacements using minimum potential energy method. I hope you have understood this. Thank you so much.